Hello dear friends. So today I am going to introduce a very important topic from the board point of view and a very important chapter you are doing, that is electricity. So today I will just focus on some practical demonstrations. Rather I will focus upon, basically first I focus upon some basic instruments that are listed in the chapter electricity. So most of the times you are not able to see the different instruments that are available in the lab actually, right? So today I will make you easier to understand what are the various instruments being listed in your chapter, and rather based using this instrument I will go with some more practicals that are quite interesting practicals, and that will quite helpful for making your concepts quite easier. Okay, so let's start with some basic instruments that will be most of the times are being used in the electricity concept, in the practicals of the electricity concept, right? So there is no need of rote learning. So let's start with the concept. So see, one by one I will show you. So this is a galvanometer, right? This is called as galvanometer. A G is written is there, that denotes galvanometer, and these are the two terminals. The red one is a positive, black one is a negative. For what purpose galvanometer is used? It is used to measure very weak currents. Okay, it is used to measure very weak currents. Okay, so if you want to determine the amount of the current flowing in the circuit, you can connect the galvanometer in the circuit. It will give you the exact reading of the current being flowing in the circuit. Okay, then second is, this is again you are seeing that here's A is being written, that denotes it's an ammeter. Okay, so ammeter is basically made from the galvanometer circuit. Okay, so this is used to measure the current in the circuit. Okay, so it can measure a large amount of current if flown in the circuit. Galvanometer is basically used to measure very weak currents, but this can be designed in any range which can measure a very weak current also or very strong current also. So this is called as ammeter, and you can also see that the scale is there. Readings are being marked, so 0 to 5. It means it is having a maximum range of 5 amperes. It can measure current up to 5 amperes. If you're going beyond 5 ampere, you need to have a different scale ammeter with you. Okay. So similarly, if I show you one more, so this is like again ammeter. Now if you carefully see, here's the written MA, that is milliampere. 1 ampere equal to 1 by 1000 of amperes. Means it is a very low range instrument. So if the circuit you are designing, current flowing is very small, don't go for amperes, go for milliamperes. Because if current is very less, so might be your instrument, if you are using ampere meter, that may not detect that particular small amount of the current flowing in the circuit. There comes a problem. Okay, so choose the ammeters or milliammeters or bigger scale range ammeters as per the circuit you are designing. So this is about your ammeters, and now this is again one more instrument. Here is written as V, that is it's a voltmeter. So voltmeter is basically used to measure the voltage, or technically we use the word potential difference across the terminals of the circuit. So this can be used to determine the value of the terminal potential difference. Okay, so again you have two terminals, red and one is black, positive and negative, and again if you carefully see, it's up to 10. The scale is go up to 10, that is it can maximally measure the voltage up to 10 volts, 0 to 10 volts. Okay, then you have this is I have shown you, this is sort of analog voltmeter. This is called as analog voltmeter. You can also use such type of the instruments. This is like a digital voltmeter. So direct numbers are displayed. There is no needle. Only direct, as we will connect across the wires in the circuit. This is on off switch, and then you will see the direct digits are representing, that is the voltage being having that particular value in the circuit at a particular you are using the instrument. So this is a digital mode instrument. You can directly use this instrument to display the numbers on this particular glass. Okay, so this is a digital one. Okay, then one thing I show you, this is a sort of, this is called as rheostat. This is called as rheostat. Okay, so a wire is wound having a large number of turns here. Okay, and this is one terminal, this is slider, this is called as slider. So there are rheostat. First of all, rheostat is used to change the resistance of the circuit, or you can say that it is used to control the amount of current flowing in the circuit. Okay, so on one side is like a maximum resistance you are offering, means less current you are giving, or if you slide on the other side, means you are going with the minimum resistance and maximum current, and vice versa. Such type of conditions can be discussed. And here are three terminals, two here for connecting the wires, 1, 2 and 3. So whenever you connecting this in a circuit, just use either one of these terminals and one terminals. This will complete the circuit. So then you, if you want to do some experiment, so either you go for having a minimum value and then slightly goes to up to the maximum value. Okay, so this is a rheostat to control the amount of the current in the circuit. And one more thing I want to speak, always remember, ammeter is connected in series while voltmeter is connected in parallel. Okay, then is one more thing I will show you. This is also, you should be aware of what is it. It's called as resistance box. Resistance box. And see, there are a number of keys on this, and the values are being written 500. If I go to this side, 1, 2, 3, 5, 10, so on up to 500. Means in this, if you want to introduce a known value of the resistance in the circuit, go for resistance box, because in this the values are being displayed. If I say, if I had put off this key, it means I have introduced a resistance of 1 ohm in the circuit. And if I put off two keys, internally they are connected in series. So 1 plus 2, that is 3 ohm. I am giving the resistance of 3 ohm, or you can, if you want to have a higher resistance, you can put off 500 plus 2 plus 1 to 503 ohm. 503 ohms, you are getting the resistance in the circuit. So this is the way to introduce a known value of the resistance in the circuit. So this is called as resistance box. Okay, then I will go with the next. So these type of the resistors are also available in your labs. So these are inbuilt in some plastic cage. So values are being written like ohms 20, it's ohm 40, right? So inside a wire is being coiled, and these are the two terminals, 1 and 2. The wires are being connected across these terminals. Okay, so this is also a resistance of particular given value. Okay, then is switch. Normally at your homes also you are using the switch. Switch is used to on or off the circuit. In labs we are using these type of the switches. Okay, this is called as one-way key. Okay, so these are again two terminals across which wires can be connected and circuit can be closed. And if this is like, if you are placing this key as it is in the circuit, it means you are having an open circuit, means current is not flowing. But as soon as you put up the key here, it implies a closed circuit. If the circuit is, you are making a circuit using this and you are putting this, it means now you are making the current on and the circuit will work. Okay, so this is, rather you can say this is a safety for your safety, because suppose you are designing some circuit and by chance you are making some mistakes while designing a circuit, so might be some short circuit may happen or some other electric problem can happen. So it's better to make the circuit, put the key off and then check it once and then put the key again back and then on the circuit. Okay, and this is also one more, this is also two-way key. It's a two-way key. If you want the current to flow in two paths, then you can use this. Like here is also, means now this circuit will work, and if I put this key here, then this circuit will work. Means you can control the two circuits at a single time. Okay, so these are called as one-way key and these are called as two-way keys. Okay, then so this this one last basic instrument I will discuss. If you don't have ammeter or voltmeter in your lab, just go for this instrument. This is called as multimeters. So in multimeter we have voltage, current, resistance, right? AC voltage, DC voltage and all. Means number of parameters are being specified on this instrument. So digital values are being displayed. So this is quite used by the lab persons, or might be at your homes also. If you see like some TV repairing, if you are doing with some technicians are coming in your home, they always have this in their hands actually. This is called as multimeter. So means to check the faults, they immediately try to want the exact value of the current or voltage being flowing at that particular time, and accordingly they will detect the particular fault in the circuit. So this is also called as multimeters. Okay, so these are the various instruments being used while you are doing some practicals in the lab, or this I have shown you is a very interesting video for you people, because most of the time you only rely upon the books, you don't have an idea what the exact instruments are look like. So I have shown you, so I hope your understanding of the different instruments is very much clear. So in my next topics, in my next videos, I will go with some more interesting experiment using these instruments, and I will show you how to connect the instruments. So stay connected with me. Don't forget to subscribe my channel. So I will meet you in the next video with some more experiments. Thank you. Take care. Bye bye.